Recording is on.
Tak můžeš. So good morning. I'm Miroslav Blaško and from Knowledge-Based Systems and Software Group, and I will present today about knowledge management tool in ontology-based system development, and I will describe requirements for such a tool based on experience that we have from previous and ongoing projects. So the outline of the presentation is to give you motivation why we are talking about the requirements. I will overview key tools that we have, overview key projects that we did, and I'll try to distill use cases and requirements for such a knowledge management tool that we need. And I try to, after that, I try to describe limitation of our tools and what we can improve. Our main use case is development of ontology-based or knowledge-based systems, and it typically is created with close collaboration with domain experts, and we require them to formalize their knowledge instead of just talking to them and formalizing it ourselves. So we developed multiple tools that should help with it. The key tools are those two. First is TermIt, which is a tool for capturing knowledge by domain, specifically tailored to domain experts. Then we have another tool, Ontographer, that supports modeling, supports conceptual modeling, more concretely UFO-based conceptual modeling, where UFO is Unified Foundational Ontology, and it builds upon the knowledge created from TermIt. And another tool that we use heavily is Protege, which is just a tool to develop application level ontologies, I would say. So the motivation here is that we already are using those tools, and they shown to bring us value, and but they do not fit all the use cases. So I will talk about it based on experience from previous and ongoing projects. Basically, at the end of this presentation, discussions should follow whether we want to improve our tool or adopt additional tools and so on. So the overview of key tools, as I said, the TermIt. TermIt is a tool that supports term creation, vocabulary creation, and it supports also discussions over terms and simple workflow to approve terms, and also text analysis of documents. So it allows to annotate existing documents, and while annotating, we can look on or looking at the document while annotating the terms and defining those terms, searching definitions from those documents and so on. Or on the other hand, we can annotate existing documents with terms defined in our vocabularies. Also, it provides full text search over terms and additional attribute of terms. Then we have Ontographer, which is targeted to ontology engineers or technically proficient domain experts. So it's yeah, and it's, as I said, it supports conceptual modeling with UFO. And the other tool is Protege, that basically supports editing of all two ontologies. So it is very crucial for developing application level ontologies. And we would use all those three tools when participating on projects or when developing software, but they are still not fully connected together, or there are some missing gaps how to integrate those tools together, because we developed only first two of them, and this is a third-party tool. The other tools that we use is GraphDB for storing triples. We use our tool SPipes to manage semantic pipelines, so RDF-based pipelines, and also Record Manager to collect data based on ontology. However, those are not, I would say, key knowledge management tools that we use. So they are just additional tools that we use. So let's go over. I selected only two projects to demonstrate the use cases, what we need to do. The first is the project related to modeling reliability, which was a project of Ministry of Education, and then it was a project. Then there was a follow-up with aerospace vodochody, and we developed system that was able to model aircraft's partonomy of components, and then do FTA analysis. This was generated also FMEA analysis, and so on. And within that project, we needed to process documents to input the data for the system. So we used we needed to extract knowledge from PDF documents, mainly from aircraft manuals, and what was needed is to transform PDF to text, or it's not what was needed. This is how we did it. We transform PDF to text, and we annotated within the Brad tool to annotate relations. Also, we annotated automatically the concepts, and we used external vocabularies to find those concepts and annotate them semi-automatically. At the end, relations were annotated within textual document, but some of the relations could be extracted from structure of PDF. So this is one of the workflows, I would say, that we do when extracting knowledge. We typically incorporate external vocabularies. Many times we need to extract relationships from structure of, let's say, PDF document typically, because some manuals are like that. And not in that many cases we needed to extract relations manually in general way. So there would be text and people would annotate the relations like this. But this is definitely one case that we needed. We also processed some tabular data, for example, ATA components or SNS components. So we had to describe the data format, to describe the columns. So this is another task for such a knowledge management tool, I would say. And another would be data collection using custom forms. We had to define some forms and also needed to describe existing questions within those forms. So this is one project, and I will mention only only one of them, because the most important use cases are occurring there. So another project was maintenance related to CSAT, which is maintenance organization, and it was within the project, within the Toucher project. And here our goal was to create a maintenance plan for aircrafts. This is how it looked at the end. And here there was a lot of processing of Excel files. Also, it was crucial here to interpret what are the columns and to model data behind those columns. So it was important to understand here are the columns, and it was important to understand what is primary key with respect to table. We typically, those tables were exports from CSAT system called AMOS, and it was crucial to find the schema for that based on the data, and to describe the schema. Here is some kind of description schema. We were solving it using S-pipes, and we add some additional constraints on the columns, and we process data through the S-pipes. Within the same project, we also did some text analysis where we imported CSV data, and we imported some external vocabulary such as ATA for components, and we annotated documents with those ATA vocabularies. Then we created vocabulary based on ATA, and based on ATA we added another components and failures. And then the goal was for such a document, for each line, to find component and failure, because there was a relation between component and failure. On each line there was a one relation that needed to be extracted. And so we were here detecting classes component failure, and we had some knowledge rules how to extract relations from each row. And it was important to have both the text and some reference to existing entities within the system, because those data were interpreted in context of those system entities. So the use case here is really import some tabular data, or I would say some textual data with references to existing entities, and then annotate them, annotate the concepts. The relations would be extracted automatically using knowledge rules, and then it would be connected to the model. And this is a reoccurring pattern that we need to realize. Not sure if we need to include the references visually, but this is typically how we did it. Those references are here only for purpose of extracting the annotated text later and to reconnect them to existing entities. So, but as I said, this is like most typical use case how we need to process knowledge from tabular data, and we don't need to manually do the relationships typically, I would say, and it is sufficient for the tool to mark down the concepts, and then it is, as I said, reconnected to the underlying entities. So that's all related to projects, and I just styled here the I would say use cases and the requirements that occurred. So for knowledge extraction, we need to extract concepts. We often incorporate existing vocabularies, and then we are annotating either plain text, HTML, CSV, or PDF. Then for relations, we have three use cases. Either we have structured, I would say, tabular data where each line represents one relation. This occurred multiple times in multiple projects already. Or we need to extract relations based on PDF or PDF-like documents based on the structure. I didn't show the picture though, but yeah, I should have showed a picture about how it occurs. And then not that often we need to use general annotation of relation within plain text. So to draw lines, or I don't know, to associate those terms into the relations. Then relating term definition, for the core model terms, we require definitions of terms. Also, it is very useful to comment on terms, and very useful to have a simple workflow of approving terms so really have something like draft and non-draft terms. For terms that are related rather to text analysis, so they are not core model terms, we typically don't need definition, and alternative labels are usually used to catch acronyms or misspelled words, and so on. Then another case is search and exploration of created knowledge. When communicating with domain expert, it is very often needed to be able to search over everything we created and to explore the knowledge. So I put those points here. So we would like to search terms by IDI, ideally the reference terms, search terms based on term attributes, search diagrams and examples by terms. So, and then basically have overall documentation of ontology, where we want to provide onto UML diagrams. I didn't mention that, but with Unified Foundation Ontology, there comes modeling language onto UML. So we would like to have diagrams like that. We would like definitely to have custom diagrams, for example, in YET, because not all things are well described in onto UML. So we need also custom diagrams, and we often need examples. And it would be very nice to be able to search by terms those things. And also, many times it would be useful to search existing models for similar terms. So if we developed already the similar ontology to search our repository of all ontologies for similar terms. Yeah, so that's all. And so this was description of all most important use cases, I would say, for us. For the development of knowledge-based systems within context of the project that we do. And now I would like to express some limitations of existing tool stack, the tool stack of TermIt, Ontographer, Protege. So currently, TermIt and Ontographer is missing support for vocabulary-based language preference for terms. So it would be nice if we can have per each vocabulary preferred language. Currently, it supports only preferred language per deployment. And this is quite limiting because we have ontologies in different languages that needs to be combined, and sometimes there is missing Czech language, sometimes there is missing English, and so on. So we cannot have one preferred language per all vocabularies, but we need to do it per vocabulary. Then when developing TermIt and Ontographer has a way of managing namespaces for vocabularies and terms. And here the main limitation is that there is no custom IRI support. So you cannot have terms of arbitrary IRI, which is then limiting to create final Protege ontology. So to use this within the Protege, because we have to stick to some predefined namespaces, I would say. Then we are still missing synchronization between TermIt and Ontographer and Protege. Also missing unified search over term documentation, because currently TermIt is the best tool to search term documentation, but of course it's much important to search also with respect to conceptual model documentation or this Protege-related documentation of the term. So as I said, we would like to search diagrams or I don't know, types within the protege that are related. I mean, data types related, modeled in protege or anything. So this is definitely important part. And yeah, we basically don't have support for publishing ontology documentation, so we need to search for diagrams within either within either Ontographer or within the files that are distributed over some drive, some shared drive or something like that. So that would be nice as well. And also we are missing scripts that would do this whole use case of annotating CSV document, extracting the knowledge from this CSV, and do this iterative process of defining vocabulary, annotating CSV, extracting knowledge, and so on over and over again. And maybe last thing that I could think of, when we defined data vocabularies, so vocabularies describing input data, we don't have any nice way how to categorize data vocabularies and other vocabularies, so it gets a little bit messy when trying to manage many vocabularies without classifying them. So saying that those are core concepts vocabularies, those are data vocabularies, and so on. So it would be nice as well. So that's all my input. We are, based on discussion, we will definitely try to focus on how to reduce those limitations of existing tools. Thank you for presentation, and I'm ready for some discussion. What do you think? What other limitations do you see, or other, I don't know, ideas? What tool to use and how to extend our tools? So thanks a lot, and let's go further with discussion.
Yeah, one thing maybe. I'm not sure if TermIt can handle very big vocabularies. I'm sure it cannot handle very big vocabularies. For example, Kai's vocabulary is like several tens of megabytes, and there is just a limitation for uploading. I don't know if that would work, if somehow that limitation is extended.
That limit is configurable. It's not.
Yep.
It's not hard coded. It's a matter of configuration.
Yeah, I thought so. So then the question is, what would be the performance with a very huge vocabulary like that? Personally, I have some. I feel like it's quite slow, but I might be doing something because I'm trying to import vocabularies and they're big, and not as big as the cars, but big enough for me to not be able to check if terms are properly defined and stuff like that. So there are errors maybe, and I don't see them. So I have to look through the log. And that's why I don't know if it's like a problem with the vocabulary, that it's not correct, or it's it's an issue with performance. So I need to finish that experiment and make sure that I have a good vocabulary that could be imported without errors, and it's big, and then see if it performs okay. What do we have any like experiment with TermIt when somebody used the big valid vocabulary?
We don't have experiments. We know that there are vocabularies with around 1,000 terms. I think the public sector vocabulary has 1,800 terms, and it works. Although that vocabulary is quite flat, it doesn't really have any hierarchical structure. But which is usually the biggest problem. Like the deeper the vocabulary's hierarchy is, the worse performance there is from TermIt.
Okay. Yeah, so I'm talking about vocabularies of sizes like tens of thousands of terms.
Okay, we haven't tried that, but there's we have instances which have tens of thousands of terms in total, not in a single vocabulary. Um, but I don't know. It's paged, so I wouldn't expect this to be much worse than usual.
Okay. And then, yeah, as you mentioned, hierarchical structure between terms. Yeah, EKRs have some like 5, maybe 8, all the way up to 8 levels of hierarchy at most. So I don't know if this is too much. It was just, yeah. And just one another thing regarding S forms. I think S forms is very good for knowledge management as well as TermIt and Ontographer. I'm not sure why you didn't included it there. Maybe you don't like something about it, but I feel like this is much more potent to collect knowledge from experts, even like formal knowledge, than either TermIt or Ontographer. TermIt is good for defining terms and for annotating documents, and Ontographer for modeling, but like for a bulk of stuff, I think forms is very good.
Yeah, I included here the record manager, so basically it's forms. But yeah,
Oh,
you,
okay,
you,
yeah.
you are right. You are right. I should focus on that. Maybe even on generation of forms that we did in this public sector related project. So generation of forms from model. But I focused on the most common use cases, I would say. So
Yeah.
okay. Anything
Otherwise,
else? Yeah, go ahead.
when we do like this table for annotation, when we generate these tables, and then yeah, this is a very specific case where we have like a very small snippet of text most of the time. Sometimes they could be quite big in this table, I mean. But there are also other things, like for example, our ongoing project where we have STPA analysis, and in the STPA analysis there is like different texts, and like one of the texts is describing the loss scenario, and there are multiple relationships in the text, And I think that's the most common case, like having a small text, relatively small text, not like a big document with multiple pages, but a relatively like small snippet of text that describes a particular very specific well, I don't want to use scenario, but yeah, scenario or situation. And there are multiple concepts with relationships among them. So it's
So
more like,
multiple
yep,
relationships, you're saying, yeah.
yeah, and it's not possible, in my opinion, to do automatically unless we maybe do some GPT style, using some sort of GPT, ChatGPT, or something like that to extract these relationships, because I'm not sure if our annotation tools are good, as good as these ChatGPT things. And but obviously, always there has to be this, as you mentioned, validation that yes, like I like this relationship or I like this concept. So that should be there definitely. And just to generalize on this idea, it's so I was saying an example from STPA, that we have some concept, and to the concept we have attached some description that obviously could be generalized to ontologies or vocabularies that we third-party vocabularies like the ATA vocabulary, which we can also apply this kind of annotation for a more general vocabulary, because the ATA vocabulary is more general than, let's say, this one where it's already used in a particular scenario. The ATA vocabulary is just for aviation, civil aviation, describing the structure of the aircraft, aligning along multiple airplanes.
Okay, Bogdan, not sure what is the point of saying this.
It's just that it's applicable also to not only data, but also to vocabularies. You can annotate vocabularies and ground them in this way in some higher level ontology, like UFO.
Oh, okay.
Or something else.
Okay, and this is something that you feel is needed for the ongoing project for the Locopera?
Not necessarily needed, but I think it's nice. So let's say we have, like, even in this case, we have aviation ontology. And so if we can annotate, we will get like terms like cockpit and cabin, passenger cabin, and things like that. I know they're not useful here, but for example, on the third line, there were found burned lamps in the cockpit. So we have burned lamps. Okay, cool. But where are these lamps? The aircraft is a huge system, and there are lamps in the passenger cabin as well. So how do we know that these lamps are, the lamps from the cockpit, which is probably much more important because the pilots probably need these lamps for something which is safety related, let's say. But or so the maintenance should focus on those, and like if there is a light for the passengers that doesn't work, is not that important. So that's what I mean. We can have multiple vocabularies and multiple relationships inside of those lines, and there is much more knowledge that we can extract and use to do different things.
Okay. Okay, any other questions or comments or something? Okay, then thanks. We can stop recording.